If you've ever found yourself on a live production, you know the real nightmare isn't always the mix. Sometimes it's just the cable run.
Oh, absolutely. We're talking about noise, grounding loops, and just the sheer distance.
Exactly. So today, we're going to cut that copper cord, so to speak. We're doing a deep dive into a solution, the Thor F-2A-B analog audio over fiber kit.
It's a fascinating piece of tech.
Our mission today is to figure out how this little box basically makes distance and noise problems, well, a thing of the past.
And it really does. With copper, you're just limited by physics. The signal degrades, and after a few hundred feet, you're pretty much done.
So this is a complete shift in thinking. Let's start with the basics. You have a transmitter and a receiver. How does it handle that conversion?
Well, that's the elegant part. The transmitter takes your analog audio, and we're talking the full range of human hearing,
Aye.
20 hertz to 20 kilohertz.
Right.
And it essentially translates that into light, a modulated digital stream of light pulses. Think of it like a super fast, super precise translator.
So the receiver on the other end is just reading those flashes of light.
It's just reading the flashes and rebuilding the original analog waveform perfectly.
And what's really clever about this specific Thor unit is that it's bidirectional. 2 channels both ways over a single fiber strand. How is that possible without them, crashing into each other?
Yeah, that's a great question. It's like having 2 different lanes on a highway. They use 2 different colors or wavelengths of light.
Oh, okay.
So they don't interfere at all. One is sending, one is receiving, all happening at the same time on one tiny piece of glass. The savings on cabling alone is huge.
Speaking of what pros care about, let's talk performance. When you look at the specs, what's the one number that just jumps off the page? I'm guessing it has to be latency.
It is, and it's a number that basically rewrites the rules for live audio. We're talking about 1 millisecond of latency.
1 millisecond.
To give you some context, it takes sound slightly longer than that to travel just 1 foot through the air.
Wow. So for any practical purpose, it's real time.
It is real time. That's why it's perfect for things like in-ear monitors on a massive stage or syncing audio across a huge auditorium. There's no perceptible delay.
Wait, 1 millisecond latency over what kind of distance? Because copper starts having issues at, 300 feet?
This is a whole other ballgame. The standard unit can go up to 20 kilometers on single-mode fiber.
20 kilometers. That's over 12 miles.
12 miles, yeah. And there are long-haul models that can push that out to 120 kilometers if you really need it.
That's just a fundamental change in logistics, isn't it?
It completely decouples the mix position from the stage. I mean, you could mix a stadium show from a control room miles away without any signal loss.
Okay, let's talk about the audio quality itself. What are we looking at for the digitization?
It's all professional grade. You get 24-bit digital bandwidth, 48 kilohertz sample rates, so the fidelity and dynamic range are excellent.
And the physical connections. I noticed it uses a terminal block, not a standard XLR. Why that choice?
That's a key detail for installed systems. Terminal blocks are designed for secure, permanent wiring. You screw the connections in. It's much more reliable than something that can be accidentally unplugged in a rack.
That makes sense. It's built for reliability.
Exactly. And on the fiber side, you've got STPC connectors, which are robust and an industry standard.
I also saw that this system is scalable. You're not just stuck with 2 channels.
Not at all. This is just the entry point. They make models that support 2, 4, 8, all the way up to 32 analog channels, so it can grow with the venue's needs.
So if you're the one managing the setup, what this really boils down to is a compact system that kills noise, makes distance irrelevant, and operates with 0 noticeable delay.
And it works in simple point-to-point setups, or even more complex point-to-multipoint applications. It's incredibly flexible.
So as we wrap up, what's the bigger picture here? Where does a technology like this take us?
Well, I think that 1 meter's latency is the key. It makes truly remote, large-scale, real-time audio production a reality. The idea that your audio source and your entire production hub can be separated by dozens of miles but remain perfectly in sync, that changes everything.
So something for you to think about next time you're at a huge concert enjoying that flawless audio. Just how far away could that sound engineer actually be? With this tech, it could be a lot farther than you think.